So like, I don't know if it's
Okay.
on the class when we smoke something now.
Alright, you ready? Yes. You can get ready. I have candy for you and everything, okay? Alright, so this is what we did yesterday while you're getting out your stuff. You had a problem where you had f double prime. It's asking you for f of x. So if that's the second derivative, you're going to have to do the antiderivative twice. So yesterday, we did the antiderivative. We had our plus c. And then we used the ordered pair that was given here to find that our c was 4. Okay, so now we're going one more time. This is my f prime. What do I want to find? F of x. So I'm going to have to do the integral on both sides again. So, integral. What is the integral of f prime called? F of x. And what will the antiderivative be of x to the 4th? 1/5 x to the 5th. Next one. Minus 2/3 x to the 3 plus 4 what? Plus c. Okay, now just to make this easier, let's change the f of 1 to an f of 0, else you're going to have a bunch of fractions. Okay, so look at your ordered pair. F of 0 comes out to be what? We just changed it. F of 0 comes out to be what? 8. So that means that 8 is the answer when I plug in 0. Which means that c has to be what? And then remember your last step, you're going to rewrite the total solution, so it would be f of x equals 1/5 x5, 1/4 x4, 2/3 x3, 4x plus 8. And that will be your answer. Okay? Now, I want to point something out to you because sometimes you'll look for patterns and stuff and they're not really real patterns. Okay, so for here, do you notice that your f prime was 4 and your f was 8 and those happen to be the constants? Okay, that the first one was 4 and the second one was 8. Sometimes that happens, it doesn't always happen. So you do have to be a little bit careful about that, not to make assumptions. Okay, so let's look at our next one. Okay, write this one down. This is the last one that we were supposed to finish yesterday. So f double prime is cosine x. So I'm going to do the integral on both sides. What is the integral of f double prime called? F prime. Very good. And then what is the antiderivative of cosine x? Okay, so snow cone, negative, negative. If I'm on cosine and I go up 1, what will be on sine? Plus, what else should I see on there? Nah, get it. Okay, then we have to use one of our points. Will we use f prime of pi 6 or f of 0? F prime of pi 6. So 1/2 should be the answer when I plug in pi over 6. What is the sine of pi over 6? 1/2. Crap, I think this was a 5/2. I must have written it down wrong, sorry. Okay, so change this to a 5/2. My bad. Okay, so it'd be 5/2 equals 1/2 plus c. And then to get c by itself, what do I do with my 1/2? Subtract. So I do minus 1/2. What is 5/2 minus 1/2? 4/2, which is 2. Now, I want to be a little lazy here, so this is what I'm going to do. Look, I'm going to come up to my f prime. I'm going to slash out the c, and I'm going to put a 2 instead. That way I don't have to rewrite the whole thing. If you do it neatly, and it doesn't look like somebody sneezed on your paper, then you can do that. Okay, so, If you did it on FRQ, it's fine, as long as it's slashed out clearly and the number's written next to it. Okay, so this is f prime. When I do the antiderivative on both sides, what is the antiderivative of f prime called? F. Okay, then what's the antiderivative of sine x? You can look back at your snow cone list. Negative cosine x. What's the antiderivative of plus 2? And then what else should I see? Okay, then we're using our f of 0 equals 3. That means that 3 is the answer when I plug in 0. Is c going to just come out to be 3 like it did on the other ones? No. The 2 0 is going to cross out, but what's the cosine of 0? Cosine of 0 is 1. So this is 3 equals negative 1 plus c. So my c is actually going to come out to be what? Add the 1 across, it would be 4. Very good. So c is 4. So then you can come back up here, slash it out, put a 4 in instead. That would be f of x. Yes, sir?
Is there ever going to be like an integral where you don't have a plus c?
No. Now, your c could come out to be 0. So the way I initially had this written, where it was a 1/2, if I'd done half minus a half, your c would have come out to be 0. So in that case, you wouldn't have to write it. But on the AP test, if you didn't have a plus c, you wouldn't get the integral point because you didn't consider what it was. So you'd put a plus c, then you'd find it 0, then you can take it away.
That's just saying there could be a constant.
Yes. Well, there is a constant. 0 is just one of many choices, right? Okay, so what I want you to do now, before we go to the notes that you just picked up, this white sheet, so I want you to get out your homework from yesterday, and I'm going to give you like 2 to try, okay? I'm going to do like 2 of them, see how you do. So I want you to do number 3 and number 5 off the front. So number 3, number 5, and then I want you to try number 22. Number 3, number 5, number 22. Now, number 22 is all review from last semester. Nothing on 22 should be new. It's not antiderivatives or anything like that. It's a review of last semester. Okay, I'm going to come bring you candy. If you need help, ask somebody next to you, ask me. And then we'll go on to your notes for today. So you want to make it power. So remember, the power is the top of the fraction, and then the type of root is the bottom. So if it's a 3 power, that'd be 3 over 2 as your exponent. And you can get out and look at your fraction examples if you don't remember from yesterday. But you should be rewriting on both of those. Oh, okay, that is not right. The reason why is when you take the x3 up, that needs to stay 1/2. Because you can take the x up, but you can't, it has to stay 1/2 in front. So then now, if you add 1 to that, it's going to be -2, but you'll be dividing 1/2 by -2. So it'd be -1 in the front. What would it be in the front wall? Divided by -2. So times by -half. Which one? This one? Okay, you forgot to just flip the fraction. So when you divide by 5 halves, what would you write it? Right, you add 1, so that's where the 5 halves is going to go. And then you have to divide by 1. Yeah.
That means actually what happened.
And then
I was, you were in.
Okay, did you hear me?
Because you want to add
Because you're close, you just have to leave that 2 on the bottom.
fraction is 2 over 2. So you add that 2 plus 5 over 2. X, hold on, 2 to 5 over 2.
Little candy.
Then you,
I've never been in BC.
I understood pre-cal.
Good job, birthday boy.
I don't know.
Negative, what was it originally? So negative sign would switch to the
so doing this, would you make it
positive
4?
cosine. And you keep the 5 in front and then positive 5.
Because you're doing the reverse exponent, you add 1, right?
I just did.
Take this move reverse. Fix this move. That's 2. Okay, so if we do that, we have 3 over 2. Yes.
I never stayed in this so like better to get tired.
So it's 4 over 2.
Randomly, how much?
You're gonna add a whole lot. 4 over 2 is only.
So are they feeding us?
It's correct.
You add
So we should.
Let's just wait and see. How did this think that?
Are you teaching that?
No, he made it up. That's, I think, why he's so proud of it. So he feels like he really did it. Yes.
Marcel!
I know what I'm doing. So I was just stuck on like the beginning of 3.
So you added it and got 5 halves. Now you need to divide by 5 halves. And when you divide by a fraction, you multiply by that.
Reciprocal.
So you what?
So if you take 1 and then multiply it by 2 over 5. So you would just get x to 2 fifths of 5. Right? And you would do with the.
Now that should maybe be a little smaller to show it's an exponent, but I know it should be x. And then what's the antiderivative of 3x? So you'd add 1, so it'd be x to the
X to 2.
2, and then divide the 2 into the 3, you get a 3 halves.
3 halves.
Yeah?
We know.
It's sine, right? Sine squared or sine.
Okay, so looking at number 3, if you are working, keep going. Okay, that's fine. But if you need help or you need to check it, when I add 2 over 2 to 3 over 2, now also look here, you should have done integral on both sides. What did we say the integral of dy dx is? Y. Very good. And then it'd be x to the 3 halves. If I add 1 is x to the what? 5 halves. Then divide by 5 halves, you'd get a 2 fifths in the front. Plus. Next term, I had a 3x. X is going to switch to a squared. Then I divide the 2 with the 3. Now it's a 3 halves there. Antiderivative of cosine x would be what? Sine x plus c. Okay? Next one, take a look at number 5. People always do this one wrong. Do you need to do a rewrite? Yes. What are you rewriting? Are you rewriting the 2x to the third? No, only the what? X to the third. So look, watch. This should be like this. 1/2 x to the -3. You cannot bring that 2 up. That's not the same. So my 1/2 stays, x to the negative 3, then minus 5 sine x. Okay, let's integrate both sides. The integral of dy dx is what? Just a y, right? And then when I add 1 to negative 3, what's my exponent? Negative 2. Then I need to divide a half by negative 2. If I do half of a half, I'm saying that weird. If I do a half divided by 2, that'd be a fourth. Now, it would be negative a fourth because I'm actually dividing by negative 2, right? Okay, then negative sign, if I go up 1 from negative sign, what do I get?
Cosine.
Yep. So if I'm on negative sign and I go up 1, I'd be on positive 5 cosine. And then plus c. Good? Okay, there's one more off the front that I didn't make you do because I wanted to just do it together. Look at number 9. What is 1 over cosine the same as? Don't write this here, but which one? Secant x. So what would 1 over cosine squared be the same as? Secant squared. So dy dx here is really secant squared. And secant squared is one of the ones that you should know. It had to be tangent at the beginning. Because remember, what's the derivative of tangent? Secant squared, and it's just backwards, right? So you would say integral. The derivative of dy dx is y. The antiderivative of secant squared is tan x plus c. Got it? Okay, turn over to the back, please. Also, BC kids, your homeworks are just due on Friday, every week. Okay? Alright, go to number 22, please. Last one. Do we want to do one more off of this page, or do y'all think you're good? Okay, y'all try 19. 19's another special. So on that one, you'd have to like distribute and then integrate. That one, you'd just have to use your rules sheet. So like, what's the antiderivative of secant squared? So that'd be tan theta. And then what's the antiderivative of negative sine theta? Positive cosine theta. And then plus c. So it's the same thing as the top. It's just written differently to where you're not solving for y, you're just doing the integral. Okay? And then if you don't remember the integrals for these two, you could look on your pink sheet, on your rules sheet. Okay? Alright, so 19. Integrate both sides. What's the integral of dy dx? Y. What's the integral of 1 over x? Special rule. Natural log what? Absolute value x plus c. Okay, then from here I'm going to plug in my point. My y value is a 5. And I'm plugging in e to the 3. Now, question. Absolute value bars turn whatever's inside them to be positive. E to the 3 is already positive, so you don't really need them. What can happen with ln and e? Cancel out. So ln and e are gone. What's that really on the right side? 3 plus c. Very good. Which means that c is what? 2. Okay, then if you want to be lazy, you can come back right here, cross out your c neatly, plug in a 2 instead. And that would be your answer. Okay? Alright, what we're going to do for the rest of class is we're going to be doing particle motion. So if you were already in here last semester, this will be exactly the same as what we did all last semester. But if you were in BC, y'all haven't done this in a while. So take a look at number 22. Okay, you are given the position of a particle. Okay, and you are asked to find the velocity. Now, it goes position, velocity, acceleration. If I have position, how do I find velocity? I take the what? The derivative. So, the first thing that you would write is velocity equals x prime of t. Okay, and now we're going to actually just take the derivative. So that should be easy, right? Okay, 3 times down on the 1/3, what happens? Cancels out. Now it's t to the what? T to the 2. Okay, next term, I have a minus 4t squared times the 2 down, it's an 8t. And then 15t, what's the derivative? 15. Okay, then I want to know when the particle is moving to the left, what sign do I want velocity to have? Positive or negative? Very good. I need my velocity to be less than 0. That's what's going to tell me which direction it's moving. So I need to set this equal to what? 0. Do you have to write 0 equals? Yes. So 0 equals. And then I'm going to factor what will multiply to 15, add to negative 8. T minus 3, t minus 5. Which means my critical numbers are 3 and 5. And then I'm going to set up my line test. Remember, for particle motion, you should call the endpoint 0. You can't have negative time. And then 3 and 5 are going to go in here. This is velocity. This is going to tell us what the position was doing. Okay, let's say I plug in 0. 0 minus 3 is negative. 0 minus 5 is negative. Multiply two negatives, get a positive. Say I pick 4 between them. 4 minus 3 is positive. 4 minus 5 is negative. Overall, negative. And then also remember, you know it's going to have to switch back, so it'll be positive. Now, how do I know that? None of these are squared, right? If it's a squared or a fourth power where it won't change sign, then you know it's going to stay the same. Otherwise, it should switch. Okay, from here, it goes up, down, up. When is my particle traveling to the left? Which interval? 3 to 5. Okay, next part says, find the expression to model the acceleration. Okay, acceleration is the what? The derivative of velocity. So I'm going to put a of t equals v prime of t. Then I'm going to take the derivative. Okay, look at your equation up here. That's velocity. What's the derivative of that? Okay. Then I want to know when velocity is increasing. Well, remember that if velocity is increasing, then acceleration needs to be positive. Because acceleration is velocity's derivative or its slope. So if velocity is increasing, its slope is positive and its slope is called acceleration. So we're going to set this equal to 0. I'm going to take my 2 out. What's left over out of 2t minus 8? T minus 4. What's my critical number then? 4. And now look ahead right here. Do you see how it's going to ask about speed? I'm going to line my equations up, or my line tests up, so that they're already done. So I'm going to put it right here below this one. 4 is in the middle. Okay, pick a number smaller than 4. Say I pick 0. 0 minus 4 comes out to be what? Negative, then positive. When acceleration is negative, what is velocity doing? When acceleration is negative, velocity is decreasing. And when acceleration is positive, velocity is increasing. So if I want velocity increasing, like the question says, which interval do I want? 4 till infinity. Very good. Because a of t greater than 0. And actually it doesn't ask you to justify, but that would be what it, if it did. Okay, letter E, now I want speed. Remember that for speed to be increasing, v of t and a of t need to have the same sign. So remember that there are two choices. They can both be positive or they can both be negative. So look on your number line. What two intervals do they have the same sign for? Okay, 3 to 4, they're both what? Negative. And then from 4 to 5, this one's negative, but that one's positive. When are they the same again? From 5 to infinity. So between 3 and 4 and 5 to infinity. We remember that? A little bit? Okay, good. Alright, so turn for me, please, to your notes that you picked up on the way in. Okay, we're going to work some problems. Here's the only thing that's different. You should already know how to do most of this. instead of them giving you position, which is the top of the ladder, what do they give you in number 1? They don't give you position, they give you what? Acceleration. So acceleration means now, instead of starting at the top of the ladder and taking derivatives, we're going to start at the bottom of the ladder and take antiderivatives, or integrals, okay? So let's read through it. Okay, it says acceleration is 2t minus 6. Then it says the particle is traveling to the right at a velocity of 8 centimeters per second. So I'm going to put right here, what time is initially at? 0. So I'm going to put then my velocity at 0 is 8. Now, quick question. If it's traveling to the right, what sign does that mean my 8 is? Positive or negative? Positive. And you should at least think about that, right? Okay, then it says at time 3, the particle's position is 8 to the right. So what is my position at 3? 8. So my velocity at 0 is 8, my position at 3 is 8, and also it says here to the right, that also implies that it's a positive 8, okay? So part A says to find the velocity. If I have acceleration and I want velocity, is that a derivative or an antiderivative? Anti. So I would put this, v of t equals the integral of acceleration, and then I'm going to do it. Just like we would have done in the fall. But you're labeling it with an antiderivative. Okay, now let's take the antiderivative. First term is a 2t. What's the antiderivative of that? T squared. What's the antiderivative of minus 6? So let's use a t, but yes. And then plus what? C. And then from there, this is the annoying thing about integrals. You do have to find that c. You can't leave it. So I would use which of my numbers here, the 0 or the 3? 0. At 0, what's the velocity supposed to be? 8. So I would plug in 8 equals 0 minus 6 times 0 plus c. Well, then c has to be 8. Yes?
So for the AP test, are we going to have to label it like that? Like v of t equals the...
You should. Some years they don't take off for it. It just depends who the person they pick to be in charge, what he decides. So if he wants it labeled, it has to be labeled. And so I would say yes, just label it. Okay, and if you practice it now, then you won't forget. Okay, so c is 8. So then look, watch. I'm going to come back up here and I'm going to put v of t equals t squared minus 6t plus 8. That's my velocity. How do I find when the particle in part B is at rest? What should its velocity be if it's resting? Should be equal to 0. So I'm going to set v of t equal to 0. So 0 equals. It's quadratic, that means we're factoring. Well, we'll multiply to 8 and add to 6. Negative 2 and negative 4. Good? Which means when is it at rest? What two times? 2 and 4. Then if I want it traveling to the left, that's a line chart. So I'm going to set up my line chart. I'm going to check to see, do I want a positive or a negative velocity for it to be traveling to the left? Negative. Very good. So I want v of t to be less than 0. 2 and 4 are my numbers. Say I pick 0 to plug in. 0 minus 2, 0 minus 4, both negative, but they multiply to a positive. So it'll go plus, minus, plus. So I go up, down, up. Hey, Kelly. Okay, so when is it traveling to the left? What would my interval be? Thanks. 2 to 4. Very good. Okay, next one says, when is the velocity of the particle decreasing? Well, if velocity is decreasing, what does acceleration have to be? Negative. Now, question, do I need to take the derivative to know what acceleration is? What did they give me at the beginning? They already gave me acceleration. So I don't really even have to find it, I already have it. So set it equal to 0. Out of the t minus 6, what's left over when I factor the 2 out? It'd be t minus what? T minus 3. which means that at t equals 3, there's a potential switch in sign. And notice I'm lining my number lines up so that when I'm comparing for speed, I already have it together. Okay, what's 0 minus 3? It comes out to be what? Negative, then positive. Down, then up. So when is the velocity of my particle decreasing? Should I put negative infinity to 3? 0 to 3. Good job. Okay?
Is it because it says set equal to 0?
Because if it's time, you would start at 0.
Oh.
So because a of t less than 0. Okay, part E, when is the speed decreasing? Do I want same sign or opposite signs for speed to be decreasing? If it's speeding up, we want same sign. But if I want it to be decreasing, I want opposite. So look on your number line. When are they opposites? 0 till 2. Then they're both negative here. Then 3 till 4. So I would say 0 to 2 and 3 to 4. Then I'm going to put because V of t and A of t have opposite signs. Okay? Next part, we want position. So we have acceleration. We found velocity. What do we need to do to get back to position? Take the antiderivative of what? Velocity. Very good. So I'm going to put S of t equals the integral of velocity. And then I'm going to do it. But in the back of my head, I know that I'm going to have to go back and find whatever my c is using my initial condition. So your velocity is right here. What's the antiderivative of that going to be? Just term by term. What's this one? Yup, 1/3 t to the third. Okay, next term was a 6t. What's the antiderivative of that? Okay, what about 8? Okay, 8t, but same thing. And then plus c. Then I have to go back and I have to plug in my ordered pair that they gave me at the very beginning. Remember right here. If x of 3 comes out to be 8, then c will be the only thing left for me to find. So 8 is the answer when I plug in 3. Now, obviously, you do not have to show this step. You can plug in numbers and stuff as you go. Okay, but if I have 3 cubed, that's 27. Then divided by 3, that comes out to be what? Okay, 9. That's 9 times that is minus 27. 8 times 3 is 24. Then from there, I'm going to combine the 20 numbers together. Negative 27 and 24 is negative 3. What is 9 take away 3? 6. So this is 8 equals 6 plus c. Then c is what? 2. So I'm going to come back up here, put a 2. Okay? And actually, I'm going to rewrite that just because there's a lot of crap on this paper. Okay, so read through the next question, and I want you to think about what 2 things you need to know for the last question. So it says, is the particle traveling towards or away from the origin? What 2 things do you need to know to answer? Okay, thank you. What 2 things do you need to know for towards or away? The sign of 2 things, though. Position and velocity. So I want you to find S of 0 and V of 0. Now S of 0 is right here. Plug it in. What do I get? 0, 0, 0, 2. What side of the origin is it on if its position is positive 2? It's on the right side. Now remember that velocity tells me which direction it's traveling. So come back up to velocity. 0, 0, 8. 8 is positive. Which direction is it traveling then? It would be traveling right? So think about if I'm on a number line, here's 0, I'm at positive 2, and I'm traveling to the right. Am I going towards or away? Away. Because I'm already on the right side, and then I'm traveling to the right as well. Okay? Alright. Let's do you think you can do the next one on your own? No? Okay, how about if you can, do it, but I'm going to do it up here, just in case, because I know it's been a while since we did all this. Okay, so look at your acceleration it's given to you. Okay, and then I want you to write for me the two initial conditions that are given to you. So they tell you two things. They tell you the velocity and the position at certain times. What is my velocity ordered pair? The initial velocity is 72. And then what else did they tell you? At time 1, 75 meters above indicates positive. So my position at 1 is 75. Okay, part A. Find the velocity. If I have acceleration, how do I find velocity? Do the antiderivative. So you would put this. V of t equals the integral of acceleration. And now you're going to do it. So I'll give you a minute to start it, and then you're going to need to find what your c is as well. So you're doing the antiderivative with your power rule, then you're solving for c. Oh yeah, I recorded it and I'll send it to you. But we learned how to do like the opposite of a derivative. So, and I'm recording this one too if you want to go back and watch it. I'll give them to you. Okay, look at this first one. So I take the t, I turn it into a t squared. Then I divide the 2 on the negative 12. Now it's a negative 6. Antiderivative of 6 is 6t plus c. Then I plug in my 0 here. I get a 72 as my answer. 72 equals 0 plus 0 plus 7 plus c. Then c has to be 72. Now, if you want to be a little bit lazy, you could just cross that out, put a 72 right there. That's totally fine. Okay, part B. For what values of time greater than 0, we already know that time has to be greater than 0, is the particle moving to the right? That's a line chart test. So, set it equal to 0. Can I factor if that first term is negative? No, we got to take it out, right? So now my t squared is positive. What happens to my plus 6 if I divide by negative 6? Minus 1t. And then 72 divided by 6 is minus 12. What numbers will multiply to 12 and have a difference of 1? 3 and what? No, we want 12 though. 3 and 4. So I do minus on the 4, plus on the 3. What are my two critical numbers then? 4 and negative 3, but then negative 3, is that allowed? Nope, so we're going to cross that out. And now we're going to set up our line test. So, here we go. 4 is my only critical number. Negative 3 doesn't count because it was negative. Okay, let's say I plug in a 0. 0 minus 4, how does it come out? 0 minus 4 is negative. 0 plus 3 is positive. Negative times a positive is negative? Ah, yes, there's a negative out here too, right? So if it's negative, negative, positive, that's overall positive. Okay, and then if we pick 5, 5 minus 4 and 5 plus 3 are positive, but the negative in the front will stay. So my particle would have been going up, then down. So when is my particle traveling to the right? Which interval? Right would have been 0 to 4. Because v of t greater than 0. Okay, when is the particle speeding up? I need to do a double line test. I already have the velocity line chart. What do I still need? the acceleration line chart. Do I need to take the derivative to get acceleration? They already gave it to you. It's right here. So I'm going to set that equal to 0. What can I take out of negative 12t plus 6? Negative 6. What's left over? 2t minus 1, which means what's my critical number inside that second parentheses here? Okay, 1/2. And I'm going to line it up right underneath my other one so that I don't have to rewrite it later. There's a 1/2. Now let's say I pick 0 to stay on the left side of a 1/2. What is 2 times 0 and then minus 1? Negative times another negative on the outside. Overall it's positive, which means on the other side you can plug it in, but you know it's going to come out to be negative. Let's go ahead and try positive 1, because that'd be on the right side. 2 times 1 is 2. 2 minus 1 is positive, but then the negative in the front flips it to a negative. So when is the particle speeding up? Do I want the same sign or opposite signs? Same signs, right? Speeding up means they have to be the same sign. So that would be from 0 to a 1/2, they're both positive. And then from 4 to infinity, they're both negative. So it'd be 0 to a 1/2, oops, where can I write it? 0 to a 1/2 union 4 to infinity. And then if you had to put a because, you'd put V of t and A of t have the same sign. Okay? Alright, look at part D. We want x of t. How do we get to position if we have velocity? Is that a derivative or an antiderivative? Anti. So you'd put x of t equals the integral of velocity. And then you're going to do the antiderivative. You'll have a plus c. You'll have to go back and find it using the ordered pair that they gave you. So look at your v of t. It's right here. Okay, what's the antiderivative of negative 6t squared? Negative 3t cubed. Oh, wait, hold on. Sorry, negative 2t cubed. Okay, then 6t would be 3t squared. 72 would be a 72t, and then a plus c. And then my ordered pair for this one, I can see is written right here. X of 1 is 5, or 75. So that means that 75 is the answer when I plug in 1. So negative 2 plus 3 is 1 left over. That comes out to be plus 72 is 73. What does my C have to be then? 2. So then I would say my position x of t equals negative 2t cubed 3t squared 72t plus 2. And that would be your answer to part D. Okay, last question and then we're done. Okay, it says at time 1, is it going towards or away from the origin? What 2 things do you need to know towards or away? Position and velocity. So let's find x of 1 and let's find v of 1. Now, technically, I don't really even need to know the number. I just need to know the sign. So if I'm plugging in 1 here, look at this. Look at these numbers. Negative 2 plus 3, that's how many? Actually, they gave us x of 1. What was it? So I'm just going to be lazy and put 75. Okay, and then v of 1, v is here. I'd have a negative 6 and a plus 6. Those are going to cancel out. Plus 72 is 72. So what side is it on? It's on the right, and it's also traveling to the right. So is it going towards or away? Because it's on the right side and traveling to the right. Okay? Don't throw this away. We'll finish the rest of these notes tomorrow. Okay? Good job. And then Kelly, don't let me forget to give you those things.
She woke up.
That's if it's a graph. If you have a graph of your BFT, you would have to do it. But if it's like equations and stuff, you don't have to do it. The only reason you have to is if it's class and you don't have the equation. Oh, no, that was like a Does that make sense? So if it's like algebra, you don't have to have that. If you have a graph, that's where you have to connect. Okay, Kelly, have you registered for any position?
No, yes, but I haven't done it. When? When did I?
Okay, so, Kevin, were you here?
I can tell you exactly what day.
So, registration's opened in December. The last day to pay is February 18th. If you pay after that, it's a $10 late fee. Yeah, you can pay online. There's a 4% convenience charge. But if you pay in the counselor's office, that's only if you pay online, you have to do the
You just have to pay $18 here.
Yes, and you do have to, when you register, you'll have to do the total registration online. You'll click that, and then Miss Grissom will have to check you're on the list and approve you. So just don't pay right away. Wait until it shows that it's clear, and then you can pay. And then also, if you need to apply for a scholarship, they have scholarship applications in the counselor's office. They're yellow like this. And then there's a part for you to fill out, and then there's a part for me to fill out as well. And then are you an Avid or no? Okay. If you're in Avid, you should just apply for an Avid one. But if not, then I don't know how much they'll help if it's already free and reduced. But it's worth trying.
It's like a lot of money.
Oh, you're taking 3 exams? So then make sure, if you fill one of those out, put, I'm taking multiple exams. Because if you're just only taking one and you don't mention you're taking several, then they might not.
That sounds fun.
Yeah.
Okay, do I have homework? Do you have homework?
We did quite a bit of it together. Bye y'all, have a good day.
Did you record it?
I did. I'll send you the link for yesterday right now. And then I recorded today. Bye, and I'll send that to you. It'll take about an hour to upload, and then I'll get it to you.